Alright, we are going to talk about how to optimize a function and identify the constraints and determine on whether or not they are maximum or minimum when we're looking at a linear programming problem. So what I'm going to need you to do is make sure that you get today's date, the page number, which this should be, looks like page number 2, the title, and the learning target all at the top before you move on. So when we talk about a problem, and you've got this linear programming problem, you're going to all these different lines are graphed, and all of this stuff in the middle is considered the feasible region based on what the word problem said, and based on all your different constraints. So at each corner or vertex of your feasible region is a vertex. And this is how you're going to determine which one's the maximum or the minimum. So what you would do is one of these would be the maximum value, one of these would give you the minimum value. So let me give you an example. So if this was the objective function that you were given, this one right here is your objective function. Make sure you write all of this down. Okay, draw a sketch of this graph, write everything on this slide down. But if this was your objective function, then you would have this vertex, this one, and this one to all check and see which one was your minimum and your maximum. Okay, so make sure that you get all of this written down, and then you also write what I write. So let's check first -1, 2. I'm going to check that one. So this is x, and this is y, and my first constraint is 3x plus 5y. This is what I'm using. So I've got 3 times x is -1 plus 5 times y is 2. Well, this is -3 plus 10, which is equal to 7. Okay, so I get 7 for my first vertex. Now let's try the next one. 2, 3. This is x, this is y. So we're using the same constraint, same objective function. And this time, instead of -1, I'm using 2 for x and 3 for y. So I get 6 plus 15, which is 21. Now I'm going to try the next part. 6, 0, the next vertex. 3x plus 5y, you're going to use the same one for all of them. 3 times x is 6, plus this time y is 0. So I get 18 plus 0, which is 18. And now this last one here, same function. This time x is -2 and y is -1. So I get -6 plus -5, or just -5. That gives me -11. So here's all my values. Which one here would be my maximum? And that would be 21 because it's the largest. And then which one here would be my minimum? That would be -4 because it's the smallest. Be sure to answer the questions at the end, and we can continue. We're going to put this together with linear programming tomorrow.